Eric Burgess here. Today we're going to be looking at the line of best fit, how to calculate that line, the equation that we need to get. We'll also be finding R. We'll be finding the correlation coefficient. And this is something that's just asked on an awful lot of tests. They typically go together. So you're going to want to make sure you know how to do this. We're going to be doing it a couple different ways. We'll be doing it using the classic formulas. We'll be doing it using the calculator. And now with the calculator, we're going to be doing it two ways with the calculator. The first way we do it with the calculator will involve getting the values that go here. So you'll still be using the formula, but we'll use the calculator to speed up the process. That's how a lot of teachers do it because they want to see that you know how to use the formula. But then we will also do it using the calculator in such a way that it just gives you R, A, and B. So the calculator can actually just directly tell you this, but some teachers do not allow you to use the calculator that way. We're also going to be doing it using Excel, which if you have a teacher that lets you use Excel, it is the easiest way. I think it's the most clear and least error-prone way. So let's just go ahead and dive right in. So the number of thefts and yard sales per 50,000 for a random selection of cities is given. So here it is. And we want to know, is there a linear relationship? And find the line of best fit equation. So basically, when they say, is there a linear relationship, we're interested to know if there are more thefts, are there more yard sales? Or if there are more yard sales, are there more thefts? That's one way of saying it. Are they somehow correlated to each other? So if we go to a city and it has a large number of thefts, we might say, oh, this is a city. It's also probably going to have a large number of yard sales. And so that's sort of what we're interested in doing with this sort of a process. And we can tell that by our correlation coefficient, R. R, when it's close to 1 or -1, if you were to graph all these points, they would wind up forming something that looks pretty close to a line. And this would be a positive one and a negative one. And basically, if every single one of these points up here lands on the line, then they are very highly linearly correlated. When we say linear, it's actually spelled like line E-R, like line R. And so that's why we talk about lines, but we pronounce it linear. And so that's what we're kind of looking for, because if they all land on the line, then it's safe to say that, other points probably land on the line. Now, of course, it's not perfect. Some points won't land quite on the line. So we're looking for the line that best fits the data. And we're going to first calculate R. And R, if it's close to -1 or 1, will tell us if there's a linear relationship. So this formula tends to scare a lot of students. It is not as scary as it seems. I know it looks scary, but it's really not. If you have your data and you've got this formula, you've already got the answer. So first notice that this is the sum. So this means they want us to multiply each x and y value and then add the results. So we should make a set of columns, for example, the xy column and the x column, because they want a sum of x's. And then over here we have a sum of y values. So we should have a y column. And we should have a x squared column, because down here we've got sum of x squared. Now be careful with this one. This one right here is a bit different. This one says it's a sum of x. So we've already got that up here, sum of x. We're going to do that with this column. But then at the end, when we have the sum of it, we're going to square that sum. So this is a bit different. It's not the same as a sum of each x value squared. This one says square the x values, then add them. This one says add all the x values, then square it. So be sure that you understand when the square is outside of the parentheses, like it is right here, that it means do this stuff first and then square it. Where over here, this one says do the squaring first and then add it. All right. And over here we have a similar deal. We have a sum of y squared, so we should have a y squared column, and then a sum of y squared, meaning we add all the y values, then we square them, just like we talked about with the x values. So these are the columns we need. And once we have our columns filled out with all the appropriate numbers, we're just going to add them all up, which is the same thing as summing them. We just add them all up, and that'll be the number. And for example, this column, the number that shows up here when we add them all, that's just going to be the number that goes here. And the same thing for X and the same thing for Y. That's why we have these different columns. Now they have one other variable in here that we don't have, that's N. And so we know from N being the number of pairs of points that we have. So if we come up here and look at this, if we were to list these off, we have 1, 2, 3, 4, 5, 6, 7, 8 pairs of points. So our N is 8. It's just 8. Okay, now let's just do a couple of these, and then I've actually already done this chart because it takes kind of a while to do the entire chart by hand. So if you have a teacher that says you can't use any fancy calculator or magic, I want to see everything on your paper, I'll show you the first few, and then we're going to fast forward a bit, and I'm going to let you finish the rest of them because there's just a bunch. So for the X and the Y columns, it's super easy. You just copy them down. So like, let's call this top one X and this bottom one Y. So X would just be 2.1, 3, 5.8, you know, on and on and on. Write out all the X values. And then at the end, you're going to add them all together and you're going to get a number. And the same thing for Y. It's just going to be 25.7, 15, and try to stay, you know, lined up. Kind of try to make it look kind of nice for whoever's going to be reading your work. 147.2. You're going to do it all. And then at the end, you're going to add it and you're going to get a number. For the X squareds, all you got to do is you just got to square each X value. So this would just be 2.1 squared, 3 squared, which, right, we know that 3 squared, well, that's 9. And then 2.1 squared, well, let's pull up a calculator. 2.1 squared, well, that's 4.41. So we'll put that in, and then you'll go ahead, you'll do that for each X value. And then for Y, you'll do the same thing. So we see here we have 25.7 as our first Y value. So we're going to put in 25.7 and then we're going to square it. Whoops, wrong button. You can come in here and actually change it after the fact. Let's just do it again. 25.7 squared. And we'll get 660.49. So 660.49 would go here. And you'll do this for all the Y values, all the X values. Now this column right here, this says to multiply each X times its corresponding Y. So in this case, the first matching pair is this 2.1 and the 25.7. So we do 2.1 times 25.7. And we're going to get 53.97.97. And then we do the next one. Well, that's 3 times 15. 3 times 15, well, that's just 45. And then we do the next one, 5.8. I'm doing a few more of these because this is the one column I see get wrong the most. That's 5.8 times 147.2. And we're going to get 853.76. So the next one will be 853.76. And you would go on, you'd do them all, and then you would add them all up at the end. And that would be the sum of X, Y. Now, I've already done this whole thing. But you would go through, you would do this entire thing, but check this out. If we zoom out all the way, what's that in the corner? I think it's what we're looking for. So let's go ahead, let's take this, and we're just going to pop it in right here. So if you were to do it by hand, you would have to do each one of these by hand, like I've done here. Write out all the numbers, show all your work, and then at the end, you simply add the columns. So when you add all of the X, Y column, you get this number. When you add all the X, you get this number, and you get these corresponding numbers. And that's how you would get it using the by hand method. And then you would pop these in the equation, which we will do, but I really quick want to show how to do the same thing in the calculator. It is extremely fast compared to this method, much faster. So in the calculator, first you need to enter your values into their lists. So go to Stat and then go to Edit. And Edit will bring you to the list you can enter. So in the first list, we're going to put our X values. And if there's something in the list, just go up to highlight the name of the list, just list 1, and hit clear. You'll see the text down here disappear, and then when you push down, the list should clear out. So now we just go ahead and put in our X values for list 1. So that would be 2.1, enter, 3, enter, 5.8. And I don't know about you, but when you're taking a test or something, you're not allowed to talk out loud. And for me, that can sometimes be a bit of a problem because I am someone who not talking out loud will cause me to make errors a lot of the time. So sometimes I'll mumble to myself or just sort of mouth the numbers. It just helps me make less errors when I'm copying. But I'll also go back and I'll double check each value because you don't want to get the answer wrong just because you type something in wrong. So I would like triple check these and just be really, really confident that you got it 100% correct and then move on because yeah, it really stinks to lose points over getting something like this wrong. So we have 81.1, 46.3, 171, and 96. That's just what an error like that would be, just like a kind of, I can't believe I lost it to that kind of an error. So let's just look at this. This all looks to be in order. Let's go up to the top. Yep. Okay, cool. So once these are all set up, you're going to go ahead and it automatically saves. So you're going to go ahead and go to the stat menu. And in the stat menu, you're going to go to calculate, and they have two variable stats. So you've probably used one variable stats a bunch, but two variable stats will actually produce all of these sums for us. So it's pretty handy. So again, you just go to stat and go to calculate, two variable stats, and enter. Make sure the X list is in list 1. If you see a different list number, or if you put it in a different list, like let's say you put list 3, you could come down here and we see list 3 is in blue right here. So you could hit the blue key and then L3 and it changes it. We're of course in L1, so we're going to change it back to L1, but that's how you would change it. And you don't need to worry about frequency lists. So we just go ahead, we hit calculate, and it calculates it for us. And check this out. They have a sum of X, 30.7. And when you add all the X values by hand, I indeed got 30.7. Sum of X squared right here, 141.35. And let's keep coming down here. They've got the Y values, sum of Y, 672.3. That checks out. 77831.23. That checks out. And then finally, the sum of X times Y is at the very bottom. Or did I pass it? Oops. I think I passed it. Let's go back up. Oh, here it is. So we got 3084.8, and that is exactly what we got. So this is also a great way to check your work. So if you do have to do it by hand, you might as well do this really quick. Put them in the calculator and just be 100% because that's like really reassuring to know you got it right. Now, okay, once we have these things, let's go ahead and use the formula, and then I'll show you another way. So the formula, all we got to do, let me make sure the formula is on the screen at the same time. So we've got R is equal to, and then we've already talked, make a big fraction bar. We've already talked what N is. We noted that N was equal to 8. So it's 8. And then I would copy the parentheses just like how they appear in the formula. So the sum of XY is this number right here, or you could look at your calculator. And we've got 3084.8. And then we're going to subtract, because that's what the formula has, parentheses, and then sum of X. That's this one when we add all the X values. So that's 30.7. And then another parenthesis, and then sum of Y, because we're doing this bit now. And that is just 672.3. Now we come down to the bottom. There's this beautifully large square root. I tend to write the square root at the very end. So I'm not going to write the square root kind of yet. And our first is N. So that's 8. And there's a parenthesis around this. Copy the parentheses. It'll make your life easier. And then we have the sum of X squared. And so here's the X squareds. And when you add them all up, this is what you get. And so that's just going to be 141.35. And then we have subtracting, and then another parenthesis. And this one has the sum of X, right? Because we're copying the parentheses exactly. So inside the parentheses is just sum of X, which is, here's the X column. So this is the sum of X, 30.7. And then on the outside of the parentheses, we put the square. So that's an easy way to just avoid that mistake. Now, I wrote a time symbol here. That symbol is unnecessary. I just wrote it there for clarity. So I'm going to go ahead and just write another parenthesis. So that's the only thing I'd probably change. And we have 8, And we have the sum of y squared, which is 7783.23. And we get a minus, and then parenthesis, sum of y, which is 672.3, and then a square on the outside of that. Now we close the last parentheses just like how it appears in the formula, and I'm going to insert that square root sign now that I know how long it has to be. So if you don't have a calculator that can enter fractions like this is going to be a bit more complicated for you. You're going to have to do the squaring first, and then keep in mind then you do the parentheses. So write this out as a number and do it. Do the same for this side. Then multiply the two numbers, take their square root, and then that'll be your bottom number. Your top number you'll multiply, subtract, and then you'll finally divide the top and the bottom. I'm going to show you a way where you can just enter it all in one shot, and it's the least error-prone way for the calculator. So let's go ahead and just open up our calculator, turn it on, and we want to go to the fraction menu. First, we need to get out of this menu, so I'm just going to hit second, and then in blue it says quit, so I'm going to hit that one. So we're on the basic screen. Then I'm going to hit green, the green key, and then F1 is the menu that has the fractions. So we're going to go up here to the fractions, and I'm going to hit number 1, numerator over denominator. All right, cool. Now on the top, we're just going to type it exactly as it looks. So it's just going to be 8 parentheses 3084.8. 3084.8. Just make sure you're typing it right. Minus parentheses 30.7 parentheses. Get another set 672.3 close parentheses. All right, the bottom's a little more complicated. Push down to get to the bottom. First, we need a square root sign. So we're going to hit second and go to the blue square root sign here. And again, we click that because it's blue. And copy the parentheses just like they look here. Now, the square brackets, just treat them like regular parentheses. So this is an open parenthesis, and then 8, and then another open parentheses. Make it exactly the same. 141.35. And then we're going to close the parenthesis like we have right here, and then minus open parenthesis 30.7, close parenthesis, and then square it. Okay, make sure you definitely do it like that, because if you don't, you're going to get it wrong. Now we're going to close parenthesis, and then we're going to open parenthesis, right? The closed one was for this big one. And now we're going to have 8, open parentheses, 7783.23, close parenthesis, minus open parentheses, 672.3, close parenthesis, square it, and then one more close parenthesis. So if you get an error, if this says error instead, you probably forgot a parenthesis somewhere and it's messing you up. Make sure you just do it exactly as you wrote it down when you plugged it into your formula. Hit enter. Oh, and see, I have an error. So when we get an error like that, typically means that something, if we typed it in exactly, that probably means we didn't copy a value down correctly. And after looking more closely, I realized that this value was written down wrong. I forgot a digit, which was making this number negative, which was why we were getting why the calculator was complaining at us. So with that insight, let's just go back up and select our previous entry. And so we're just going to take that, and this time we're going to come in and merely add that value in. So you don't actually have to retype the entire value, the entire thing. From here, you can actually go to the insert mode. So we're going to go to second, insert, and we're going to put a 1 in there. It's going to put it just before where your cursor's at, and we have fixed our problem. So let's go ahead, hit enter, and there we go. We get our R value. So we found that R is equal to about 7124. And so with this, we can actually say how good the linear relationship is. Generally, in most classes, the linear relationship needs to be over 0.85 or 0.85 on the negative side. So 1 to 0.85 and negative 0.85 to negative 1. These are the acceptable ranges in most cases for what people would consider, there's evidence of a pretty strong linear relationship. So this is a very weak linear relationship. So we would write, weak linear relationship. relationship. And we would argue this on the basis that R, the R value, that it's not closer to 1. So it'd say, oh, it appears that, if there are thefts, there will be more yard sales in this case, but it doesn't appear too much to be like that. And the reason we say it appears that there'll be more than is because our R, our correlation coefficient, is positive. So that's how you do this using the calculator and just typing it all in. Now, for A and B, I'm going to let you go ahead and just pop them in yourself. So you've seen they use the exact same thing, sum of y, sum of x squared. You literally just put it in the calculator, write out your formula, put it in the calculator, you'll get A and B. What I want to show you is how to do it using the calculator. So if we come over here and go to stat, this is like the full-blown calculator method. You can actually come to calculate, and if you go down, there's a linear regression equation that you can use. Now this will give you just A and B. And also these equations, there's two versions. There's a bx plus A and an ax plus B. And so we're going to pick the one that matches ours, but if you pick the other one, you can actually just flip the values. So ours has bx plus A. And so we're going to go down to where there's a, now this one says A plus bx. That's the same thing. The B is next to the X and the A is off to the side. So we're going to choose 8. We're going to hit enter. Our X list and Y list have already been inputted. And we leave everything else alone. We hit calculate. And we get an A and a B. So now we can write down that A is equal to 1.732. And if you want, you can use the equations exactly like we just did with R. It's quite a bit simpler. And then B, meaning simpler than R, is 21.45. And so so this is A and B, but this is not the equation. I see a lot of people stop here and they're going to get it wrong. You didn't write down the formula. So the formula relates Y and X. So we don't know one of these. So if we know an X value, we can plug it in and get a Y value. And if we don't know Y, we can plug it in and get an X. That's the whole point. And our formula was Y equals, and then if we come back up here, BX plus A. So we don't know Y and X. So we just write Y and X. So we have Y equals, and then for B, we had 21.45, and then plus A, it's BX. So we put our X down. We don't know what X is. We would pick an X in order to determine a Y. We'd plug it in. And then we'd say plus 1.732 plus A. This is BX plus A equals Y. It's a gross looking Y. Let's make it look nicer. But this would be the formula that you would actually write out. So at this point, we've actually answered the question. However, on the calculator, this is great for A and B, but what about R? Well, check this out. If you go to stat and then go to tests and then push up and go to F. You can push down, but it's just a bit faster if you go up. Linear regression t-test. This will actually give us R, R squared, A, and B. So it's actually really convenient. So we're going to hit enter on F. Make sure X and Y are chosen appropriately. They got the correct lists. Then we're going to go to calculate. And if we look here, we have an A of 1.732, which is what we got. And we're going to have a B of 21.45 approximately. And then we get an R squared and an R 0.7124. So that is how you do it using the calculator. You just go to stat, tests, and then F. For linear regression t-test, it happens to give us all the values that we could want as long as you give it the correct lists. So now let's go ahead and do it in Excel. So first we need to put these values into Excel to let it know that what we're going to be working with. So we're going to come to Excel. Let's just come in here, and our first values will be our X values. Our next values will be our Y values. And in Excel, all you need to do is type a value in, and if you enter, it'll go to the cell below it. So it's 2.1, 3, 5.8, 2, 2.2, 3.5, 6, and 6.1. So it's actually a lot faster to enter, and I feel a lot more confident putting it in this way. Now for Y, that's going to be 25.7, 15, 147.2, 90, 81.1, 46.3, 171, and 96. Whoops, put 93, 96. All right, cool. So now that we have these here, we can actually already find the correlation coefficient. Excel has a function called correlate, or correl in this case. So it's correl, and don't forget to type equals, let it know we're doing a function. And it wants two arrays, and array is just a list of number. In this case, it's actually our data. So array 1 is all these values. So we just select them. And then we do a comma to move to the next one. You see it even turns dark gray to let us know we're on that one. And we select those. Close parenthesis and hit enter. And look at that. We get R. In fact, we could even type it here. R. R is equal to that. Or, okay, so that's how you get R. But if you want the formula, that's also really easy to do. Simply select your X and Y values. In fact, even select the title. So select the titles and everything. Go to Insert. And then they have a scatter plot. Go ahead and click on this scatter plot icon and go to scatter. And it will just give us our plots pointed. So like 2.1, 25.7, 2.1, 25.7 right there. You can see it listed out. And so in here, you can actually come in, right click on a piece of data. You have to click right on the data. So right click on it and go to add trend line. When you add a trend line, wait for it. There it goes. It pops up and also does the format page. But if you don't get the format page, just go ahead and right click directly on the trend line and go to format trend line. And this area will pop up. And this is the line that is the same thing as the equation we just had. So we can actually say, hey, display the equation right here. So we click yes. There's our equation. Look at that. It's the exact same equation, 21.448x plus 1.7325. The exact same equation. And we can even get the r squared value. And if for example, you didn't want to use the correl function, you could actually take this value and take the square root of it. We could say equals to square root. So you could just use the chart for all of it, 0.5076. That's r squared, so the square root would give us just r. Look at that. Now it's going to be a little off due to rounding error because we're only doing 4 decimals where we know that r is a much longer number. But now we have r. This is also r. Then we got this from r squared. But that's how you do it with Excel. If you have any questions about this, let me know, subscribe, and we'll see you in the next problem.